We're going to prove that the limit as x approaches 0 from the right-hand side of the square root of x equals 0. Now, first of all, looking here is a graph of our square root of x, and so we're going to be approaching this from the right-hand side because it's undefined here on the left-hand side. And so we will just have a 0 plus epsilon, so we can see we'd just be able to go above, and then we would just have a 0 plus delta here because we just have the right-hand limit. All right, so we want to say that given an epsilon greater than 0, we want to find a delta such that we could write this as 0 less than x minus 0 less than delta, like traditionally, except that we don't need to put in the 0 and we don't need the absolute values because we are just approaching from positive from the right hand side. So we could express it like this. Then if this is true, we want to show then that the absolute value of the function square root of x minus what we say is the limit 0 would be less than epsilon. So let's start with this. And what if we take this and we square both sides? Then we have the absolute value of x less than epsilon squared. So if we let our delta equal epsilon squared, this should imply that the function value and the limits difference is within epsilon. So let's go ahead and show that. We're going to choose delta equaling epsilon squared. So then if 0 less than x less than delta, then we could take this and square root both of these. The square root of x is less than the square root of delta, but we know that delta was epsilon squared, so this would be the square root of epsilon squared, which would be epsilon. So given that 0 less than x is less than delta, with our delta being epsilon squared, we just showed that this would be true.